Welcome to Task 1. Task 1 is iris flower classification. First of all, I'm importing the library, which is pandas for reading the file and performing certain activities. Then I'm visualizing the data, which is using Seaborn and Plotly. Then I've imported label encoders, min-max scalars, logistic regression. For validating the model, I've used accuracy score, precision score, confusion matrix, R2 score, mean absolute error, and classification report. First of all, I'm importing the iris dataset with index column as ID. Then, on basic exploration of the data, first of all, I'm looking at how the data looks like. So, using the df.head command, I can see that sepal length, sepal width, petal length, and petal width are the four input columns, and species is the output column. And it is also clear that these four input columns are all numeric columns, whereas species is object or contains string values. Then next, I'm finding the shape of the dataset. So the shape of the dataset is 150 rows and 5 columns. Then I'm looking at the data types of the dataset. We can clearly observe that sepal length, sepal width, petal width of an iris flower contains all the float values, whereas species is an object column. Next, I am seeing at the mathematical lookout of the data. Here we can find the count, mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and maximum value of a particular column of the dataset. Then I'm checking the null values. So all the values, all the columns contains no null values. Since the values over here is 0, meaning that the data columns does not contain any null values. I'm plotting the correlation matrix between the columns. Using the sns.heatmap, I've used df.correlation to find the correlation between the columns. Numeric only is kept true with an annotation. Here we can easily understand that petal length and petal width have a strong correlationship. Then going on to the exploratory data analysis. First of all, I am doing the univariate analysis using Seaborn libraries. First of all, I've box plotted the sepal width centimeter. Here, I found out that there is some outlier in the dataset. We can clearly see over here. Then I'm plotting the dust plot of the sepal length, and the density curves look same as that of the Bell's curve. Scatter plotting the petal length centimeter, we can clearly see that easily classify these data points separately, and then I've plotted the histogram of the petal width. Then individual strip plot, we can see over here that sepal length has variance of the data between 4.5 or 4 till 8. Then sepal width lies between or ranges between 2 to 4.5, whereas petal length lies between 1 to 7. But also there are some data points which is easily separable. Same goes with the petal width. starts from 0 and ends till 3. So since we have detected the outlier in the sepal width, I am taking only the quantile to set upper and lower limit. So upper limit I'm setting to the 99th percentile and and lower limit to 1%. Then I'm removing all the outliers and considering those values which is greater than the 1 percentile range and less than the 99 percentile range and saving it to the data frame itself. Then I'm doing a bivariate analysis on species versus a sepal length centimeter. Again, a bivariate analysis using sepal width centimeter and species with petal length centimeter and species and petal width centimeter species. On scatter plotting these points, which is petal length centimeter and petal width centimeter, classify into different types of species. Here, petal length and petal width of a particular flower, which is we can see over here that Iris setosa is easily distinguishable, whereas Iris versicolor and Iris virginica has some data points merged towards itself on comparing with the petal length and petal width. Similarly, I've also drawn it for petal length and sepal length, then goes for sepal width and petal width. On multivariate analysis of these columns altogether, we can easily classify the Iris setosa plant. But in order to classify Iris virginica or versicolor, there is a slight merge of the dataset between them. This is how, on plotting 3D data with the sepal length, sepal width, petal width, using the Plotly library, we can 3D visualize the data, like how the data has been plotted onto a graph. And we can easily see that it is hard to describe, or there are some points of Iris virginica like this present in Iris versicolor region. Similarly, there are also some points such as Iris versicolor lies in Iris virginica. So there is a slight merge in the dataset of Iris versicolor and Iris virginica. So starting with the data splits, I'm considering output column as species and the rest of the columns as my input dataset. Then I'm label encoding the output column, which is the species column, as it contains data which is Iris setosa, Iris versicolor, and Iris virginica. Then I'm splitting the data into X train, S test, Y train, Y test, and the test size to be 25%. Then I'm training the model using the logistic regression model in the sklearn library. Then I'm fitting the model onto the X train and the Y train dataset. After that, I've calculated or predicted the value of Y pred using X test. Finally, on evaluating, the accuracy score of Y test to Y pred is 97.3%, whereas the precision score also comes out to be 0.97 and R2 score is 96, whereas the mean absolute error of the total predicted model is 0.027, which is good. Here is the heat map or the confusion matrix that I've drawn, which which gives us the understanding of the data set, of the testing data set we have considered. And finally, this is the classification report. The precision of calculating whether a given flower is Iris setosa or not is 1. Recall also tends to be 1. Further, it can be understood that the accuracy is 0.97% of this model.